Hello and welcome to part 2 of Advent of Code. So we are going to focus on day 2 today. I've got a little bit of code already up here as an example. Let's switch over to the Advent of Code actual question for the day. Day 2, password philosophy. We can see here, okay, I'm not going to read out the entire thing. Basically, we get a puzzle input that is a list of passwords, and we have a corporate policy when that password was set, and we have to test whether or not certain passwords are valid. So each line gives the password policy and then the password. So the password policy here is 1 to 3A, and then we have a colon, and then we have A, B, C, D, E. Okay. The policy indicates that the lowest and highest number of times a given letter must appear for the password to be valid. So 1 to 3A means that the password must contain A at least 1 time and at most 3 times. In the above example, 2 passwords are valid. The middle password C, D, E, F, G. This one does not have a B in it, and it is supposed to have at least 1 B in it. They contain 1A or 9C, both within the limits of their respective policies. Okay, 2 to 9Cs. Okay. So we're going to use this as the template for our text input, kind of like how we did last time, right? Oh, that's day 1. Let's pull up the input for day 2. Here's our day 2. I kept the same function here, so we've got read, strip, and then a split on new lines. What I think we should actually do here is create a custom function for parsing these lines. And we're going to probably just call it parse line. And this will pull out the starting range, the ending range, the letter, and then the actual password that was being used. So we're going to let's create a function here called parse line, def parse line. And we're going to have a record or a line. Let's just call it a line for the sake of ease. And we know that we've got some information here that's going to be pretty consistent. We've got white space in between the range, and we've got more white space in between the letter and the individual password. So we can actually just start off by saying R, or I'm going to use R instead of range, because range is a keyword in Python, so I don't want to do anything to mess with that. Letter, and then the password, and we're going to split. So record or line dot split here. Okay. So now we've got our R, letter, and password. Okay. We're going to create a new data object, which is going to be called parse line pass. Oh, I called this pays line. Parse. Spelling is hard. Spelling is hard. Line for line in data. Okay. So we've already split the lines individually by those new lines that they gave us, and we're going to parse each line, and we should end up with something like. Well, let's actually print it out. Let's see what we've got. Parse print data here. Let's actually just print it out for the sake of showing you what that looks like. None, none, none. So we're not actually returning anything in here. So let's just print R letter password right there. There we go. Okay. So this is what it's actually printing, which is the exact same as the input line, right? We split on the white space, and now it's just printing these 3 values with a white space together. So it's not actually outputting anything. Okay, so now we've got also our letter. We know here that the letter is going to have a semicolon or a colon after the individual letter, right? So let's say letter is going to equal letter. Oh, and we're going to say that it's just going to be the very first character of that letter. So we're gonna essentially get rid of the colon in there. Okay, and then next, let's see. So we have this range, and we need to turn that into a start range and an end range. So we're going to say start is going to be int r, end is going to be int r, but we know that we have this hyphen, this dash in the middle that separates it. So we're going to say r dot split, and we're going to essentially do another split here on the, and we're going to take the first one, that's start, so it's going to split on the hyphen, and the first value is the start value, and then we're going to do the same thing here, except that we want the second value, which is going to be the 1. Okay, so now we're going to return here, we're going to return start, end, letter, and password. Okay, and this will parse all of that data into those values down here. So if we rerun this, there we go. Okay, so now we've got a list of tuples: 1, 3, A, B, C, D, E, 1, 3, B, C, D, E, F, G, which is invalid, etc. Okay. So now we're going to pass the data. Now that we've parsed the data, we're going to pass the data into part 1, and then we'll have a function for part 2 later once we get to part 2. So let's start off by actually trying to solve this now, right? We now have to actually build the function that solves it now that we've parsed the file. Okay, so in the above example, we need to count the number of times that letter shows up, and it has to be greater than or equal to 1 and less than or equal to 3. It has to be within the range of 1 to 3. So we're going to say for, oh wait, actually we can simply say for record in data, right? We've got our record in data, or we could say, yeah, for record. I don't want to say line because we already parsed the lines. In data. So for record in data, we're going to count the number of valid records. So valid is going to start off with 0. We're trying to determine if it is in fact valid, and this is going to be based off of the password needs to have a count of the particular letter. Needs to be less than, greater than or equal to the start, right? And it needs to be count letter needs to be less than or equal to the end range, right? And if both of those things are true, then we can say that that valid plus equals 1, and we can then at the very end return the valid number. Okay, now we don't know what password is, we don't know what letter is, we don't know what start and end is. So what we're going to do is we're going to say, we're going to take something. We're going to do something. Okay, yeah. So we know that the very first record is going to be start. So start is going to be record 0. End is going to be record 1. Letter is going to be record 2. And password is going to be record 3. Okay. Now there's actually an easier way to do this, where we can just say start and letter password equals record. Okay. Now this is all because this is already a tuple. This is already a tuple, and it's just expanding out those tuples so that we can reference each of those pieces. So theoretically, if I did this correctly, this will actually spit out the correct value. Let's check here. 2. Okay, yep. So if we double check here, the correct answer is 2. If I remember correctly, where is it? There we go. 2 passwords are valid. Perfect. So we did that correctly. Let's get rid of some of our print statements here. Let's clear this out. We don't want to print the data right there. We do want to print the answers because we need the answers. Okay. Passwords are valid according to their policies. Excellent. Okay, so let's take this. We're going to open up our input.txt file. We'll save that, and then we'll print this out. 439. Theoretically, that is the correct answer. We'll see. Bam! Correct. That was the correct answer. So let's continue to part 2. While it appears you validated the passwords correctly, they don't seem to be what the official Toboggan Corporation authentication system is expecting. Okay, so each policy actually describes 2 positions in the password. 1 means the first character, 2 means the second character, and so on. Exactly one of the positions must contain the given letter. So basically that means that, so 1 or 3, right? So position 1 or position 3 must contain A, but not both. They cannot both contain A. So this is valid, this is invalid, and this is invalid because both locations cannot contain the letter C anymore. So this is slightly different. So let's jump back over to the code. And let's dive into part 2. So once again, we're going to follow a similar pattern. Valid equals 0 for record in data. This is relatively straightforward. Whoops, I didn't mean to cut that. I just want to copy it. So we've got our start, end, letter, password equals record. And we need to throw in an additional count in here. So we need to say if password at the start, but they're indexing off of number 1 here, right? So the first one, A, and 3, so those locations cannot both be the letter A. So what we need to do is we actually need to say start -1. So if password start -1 equals letter, so we'll say that, and we need to check that it's one or the other. It cannot be both. So we'll say not equal to password end -1. Okay, so we'll put some parentheses around here. There we go. So if those are not equal, which basically means, okay, if this evaluates to true, this one cannot evaluate to false, right? It will, basically, if this evaluates to true, we don't want this one to also be true. If this one evaluates to false, we want this one to be true, and they are not supposed to equal each other in terms of the letters being the same. Hope that made sense. Okay, so then if those are the same, then we say valid plus equals 1, and we return valid, just like that. Okay. Yeah, let's test this out. Let's see if we get back. Okay, so that's 584. We actually have more valid this time than last time, which is interesting. Did I do something wrong? Let's test it out. Well, there we go. It was correct. Now, there's probably a way to sort of condense some of this code. This is interesting. I like the parsing of the lines first and foremost. This one we can probably condense, right? So if so we say if start less than or equal to password dot count letter is less than or equal to end, right? This is actually more compact and should give us the same results. Yep. So basically we're saying this needs to be less than or equal to this, and it needs to be less than or equal to the, and this value needs to be less than or equal to end, the end value. Plus equals 1. There's got to be a better way to condense this, probably using a sum, actually. Part 1 valid. Let's see here. For record start. So this we can actually just say okay. So if that evaluates to true, then we can just sum all of those together. So part 1, we can just say sum map part 1 onto the data. Right? Record data. Let's see. Hey, look at that. Okay, so we can condense this further. Basically, we're mapping this part 1 function, and part 1 will return true or false of whether it passes, and that will then sum the trues together, because true is 1 and false is 0, so it will sum all those together. Interesting. So we can actually do the same thing for this particular function, where, oh, whoops, there we go. So we've got this right there, and then we can just say we want that part here, return that, and we can get rid of that, and we can just say sum map part 2 onto data. There we go. And we still don't have a record, and that's because this needs to be record. There we go. This needs to be record. There we go. Okay, so let's try this again. Perfect. 439, 548. Much more condensed. It takes a little bit of a nuanced approach using sum and map, because map this returns true or false, and you need to know that sum essentially true evaluates as 1 and false evaluates as 0, but that's still much more condensed and helpful to know and good to use. There we go. Okay, so that's everything for this particular video. If you have any questions, comments, let me know below the video. I'll be sure to respond and answer those things. If you like the video, please give it a thumbs up. Like, subscribe to the channel. If you want to see more videos like this, I'm planning on continuing this series. It'll be a series of hopefully 25 videos if I can get through all 25 days of Advent of Code, and we will get everything together that you need. So there you go. All right, have a good day. See you in the next video.